Hello, you're welcome. Today we're going to advance more. Today we're going to evaluate the limit as n is approaching infinity of the sum over k from 1 to n of 1 divided by n plus k plus 1. Oh my god, this is really cool. Now, let's start with the following substitution. So here we have k plus 1. So let's call that k, right? Now we know if k is approaching 1, the other k is approaching 2, right? Then we're going to integrate, we're going to take the sum from 2 to n plus 1. So here, this is same as limit as n is approaching infinity, then sum as k goes from 2 to n plus 1. So here we're going to have 1 divided by just n plus k. That makes sense, right? Okay. Now take note of the following. This is same as limit as n is approaching infinity, right? So here we're going to have the following. If you take this sum from 1 to n plus 1, right? Then remember this sum is going from 2 to n plus 1, and we want to take it back from 1 to n plus 1 of 1 divided by n plus k. Then we have to subtract when k is equal to 1, right? So if k is equal to 1, we're going to have 1 divided by 1 plus n, right? Okay, now, so from here, this is same as limit as n is approaching infinity, right? So if you want to take this sum from 1 to n as follow, we have sum as k goes from 1 to n. Then we're going to have 1 divided by n plus k. Then do not forget that we have to substitute n plus 1 for k, right? So we're going to have 1 divided by n plus 1, right? And then minus 1 divided by n plus 1. Okay, we're proceeding. Now, this is same as limit as n is approaching infinity. So here, this is sum as k goes from 1 to n. We have 1 divided by n plus k. And here plus, right? So we have 1 divided by 2n plus 1, and then minus 1 divided by n plus 1. Now we can take the limits separately. So here we have limit as n is approaching infinity, we have sum as k goes from 1 to n of 1 divided by n plus k. And then plus, here we have limit as n is approaching infinity. So here we have 1 divided by 2n plus 1 minus 1 over n plus 1. So if you check this limit at this right hand side, it is equal to 0, right? Because if you make your direct substitution, you see that this is equal to 1 divided by 2 times infinity plus 1 is infinity, right? And then minus, also we have 1 over infinity. And 1 over infinity is 0, then minus 0, so this is giving us 0 at the right hand side. Did you get the idea? Okay, now the limits at the left hand side, we're going to make use of the Riemann sum, right? But before we do that, we need to rewrite the limit. So here, do not forget that this part here, that this is equal to 0. So here we have to evaluate the limit as n is approaching infinity of sum as k goes from 1 to n. We have 1 divided by n plus k. So this will be same as limit as n is approaching infinity. Okay. Now we're going to divide the numerator and the denominator of the sum by n. So if you do that, we get sum as k goes from 1 to n. This is going to be 1 divided by n divided by, here we're going to have n plus k divided by n. Now this will be same as limit as n is approaching infinity. So 1 divided by n at the numerator, let us put it down here. And then we're going to have the sum as k goes from 1 to n. So here we have 1 divided by, so here n divided by n is 1, and then plus here, this is k over n. Then according to the Riemann sum, this is equal to integral from 0 to 1 of 1 divided by, then we have x plus 1, and then dx. This is awesome. So from here, this is equal to the ln of x plus 1 with our limit running from 0 to 1. And when you take the upper limit to get the ln of 2 minus the lower limit to get the ln of 1, which is simply equal to ln of 2 minus 0, which is equal to ln of 2. So this here is our correct answer. Please, if you really enjoyed the video, kindly support the channel by subscribing. Also like, comment, and share.